Do you want to score full marks in quadratic equations of 10th CBSE? Then this video is for you. Please watch until the end in order to score full marks. And I am Rama, I am my math teacher, and I'll be telling you how to avoid some common mistakes and also suggest some tips to follow in this quadratic equations chapter. So let's get started. Quadratic equations. Quadratic, that means its meaning in Latin is square. So the equations will be in x single variable and the degree will be 2. So the standard form of quadratic equation will be ax square plus bx plus c. So the highest degree will be 2. And where a is not equal to 0. You might have noticed this, a is not equal to 0. Have you ever thought like why a is not equal to 0? What makes the difference if a is 0 of a or a is not equal to 0? You have to give actually a thought to such words. It will be covered mostly in the theory part, and I know many children will ignore the theory part. Please, children, do read each and every line. Even though it's a math subject, please read every line, and these kind of things will be helpful in solving the bits MCQs, for example. So here a is not equal to 0 means, if a, what happens if a equal to 0? Let's see that. If a equal to 0, so if this is 0, the x square term itself will be a 0. Then it will be just bx plus c form. So it's forming a linear equation. So which is not true according to the quadratic equations definition. Hence, a should not be equal to 0, but it can be like b is equal to 0 and c is equal to 0. So if you consider some examples here, x square is still a quadratic equation because even though it doesn't satisfy its standard form because the degree is 2. This we have to look at even though we have b and c or 0. And next equation, x square minus x. So here we don't have a constant term, hence still it is a quadratic equation. Here x square plus 2, here bx term is missing, but still it makes a quadratic equation. So these are the common mistakes children do, like if they don't see this form, they'll simply say that it's not a quadratic equation. So that is one of the tips here. Let's see a couple of questions whether they are quadratic equations or not. Okay, the first mistake you guys do is, suppose when we consider this example, it's like x plus 2 whole cube, and here we have x cube term. So immediately what you guys think is that it's a cubic equation. So immediately you will say that, I mean, you will answer it as a not quadratic equation. But still here I suggest you not to go just blindly, simplify and then decide whether it's a quadratic or cubic equation, because simplifying itself will tell you what the equation is. And here, so it's just given like in single variable x, I mean the degree is also 1 according to this, but when we simplify, let's see. So x into x squared plus x plus 8 is equal to, and here there is one tip, like x plus 2 into x minus 2. This is the form of a plus b into a minus b. So just simply a plus b into a minus b is a square minus b square. So x square minus 2 square. And here most of the children will just multiply using distributive property. So here I tell you, like just follow some identities. First of all, you need to identify in what form the equation is. Then this is very easy for you and it also saves some time. Okay. So here by seeing this, again children will stop, you guys will stop immediately by seeing this, that thinking it's a quadratic equation as the degree is 2. But here is the mistake you do, like x square, if you cancel, see x square is common on both sides, so you can cancel, right? So the term only x is remaining, so the degree is 1. Though it appears to be a quadratic by seeing this equation, still I suggest you to simplify and then decide. Let's look at the next example. And here if you notice, it is in the form of a plus b whole cube. So just expand it. A cube plus b cube plus 3a square b plus 3ab square is equal to x cube minus 4. And here without solving, we can just blindly go like x cube and x cube we can cancel, and the remaining equation is here in the degree 2. So it's a quadratic equation. Again, children, please don't solve beyond this. Here itself we are able to identify that it's a quadratic equation. Right. Let's look into the next topic. Now let's look at one more example. Like we have root of 2x plus 9 plus x is equal to 0. When we get questions like this in the form of roots, obviously we go for squaring on both sides, because squaring will remove us the root. So that's one of the tip actually to remember. So let's square on both sides. So this is whole square. Children, please remember, when you are squaring on both sides, please put a bracket and then square. Here we have only single term, just we can square directly. But here, as we have two terms individually, like two terms, we have to use brackets while squaring. Most of the children do mistake here. They will just go like this, 2x plus 9. So squaring means like this, x square is equal to 13 square. This is very wrong. Please remember, this is a wrong method. Always put brackets when you want to square if you have multiple terms. So let's expand this. So it's again in the form of a plus b whole square. It's a and it's b. So a square. So put brackets plus b square plus 2ab. Am I right? Yes. So again, root square will be cancelled, and but still, even though we squared on both sides, we are ending up again in a term root. So what we have done is wrong. Instead of this, let's try in another way. So this is wrong. So root 2x plus 9. Here when I get a root only in a single term, and then if I square, then that will solve our problem. So in order to do this, let's send this x to the other side, right? Do you think this will solve our problem? Because here we have only single term. This root is for entire 2x plus 9. Okay. So now let's do squaring on both sides. So 2x plus 9 root whole square is equal to 13 minus x whole square. Isn't it easy now? So root square will be cancelled. 2x plus 9 is equal to, again expand here. It's in the form of a minus b whole square. So a square plus b square minus 2ab. So we have 2x plus 9 is equal to 13 square is 169 plus x square minus 13 to 26x. Okay, when you solve this problem, like we have got x square term and x term, x here, and then 9. Just simplify the terms and then get into x square plus bx plus c form. Then split in the middle term and solve. Please do try this problem once you watch this video. That's how you'll practice. And here the main tip you have to remember is that whenever you get an equation like this, if you want to remove root, then the root root has to be in a single term. So this procedure did not work. So immediately go for this procedure. In exams, I do suggest you that to follow and practice such examples ahead, so that you won't waste your time during the exams. Okay, let's see this example. Again, this example is in the form of roots. So if we are asked to solve this equation in the using a split method, suppose split in the middle term method, and most of the children will get confused by seeing the roots, because we haven't come across the roots, more common. So just without getting panic in the exam, try to solve this. So we have to multiply these two terms, like 4 root 3 into minus 2 root 3, which is 4 2s are 8 into 3, minus we have to carry root 3 into root 3 is 3. So that is minus 24. So the product of the terms is 24 and the sum of the terms should be 5. So hence it's easy. Like we have the factors here itself. One is minus 8, 8 and 3. You can actually go for plus 8 comma minus 3 in order to solve this problem. So now it becomes very easy. 4 root 3 x square plus 8x minus 3x minus 2 root 3 is equal to 0. So this is our equation. Now let's take 4 as common here. 4x. So remaining is root 3 plus root 3x plus, when we get 4x outside, what is the remaining? It's 4 2s are 8. 2. Again, let's take 3 as common. Does 3 work here? No, root 3. So when I take root 3, so 3 can be written as root 3 into root 3. And hence since 1 root 3 is outside, we will get root 3x minus root 3 is already outside plus 2. When you take minus as common, the symbols inside the brackets will be interchanged, because see, here minus 3x and we got plus, here we have minus 2 root 3, we got plus. So when you just open the brackets and just send the minus symbol inside, we'll get back the same terms again. And so 4x minus root 3, let's take these two as common. These are common terms. Root 3x plus 2 is equal to 0. So this is very easy, like without most of the children, without any confusion, just go with the process which you know. Okay. Let's look at the next example, like x minus 1 by x minus 2 plus x minus 3 by x minus 4 is equal to 3 1 by 3. For such problems, I mean these problems are in the form of fractions, so the easiest way is taking LCM. So here most of the children are doing mistakes, how to take an LCM for terms like this x minus 1 and x minus 3, some expressions. So here for the denominator, we can take x minus 2 into x minus 4 as LCM. Like, and now we already have x minus 2. So from this, we don't have x minus 4. Hence, multiply x minus 1 into x minus 4. Okay. So the term which we don't have, we have to multiply with the term. And here also the same. So we already have x minus 4. Hence, we'll go with x minus 3 numerator into x minus 2 is not there. So let's go with x minus 2 is equal to, it's in the mixed form, mixed fraction, like 3 3s are 9, 9 plus 1 10, it's 10 by 3. Okay. Now it's a normal method, like you can just simplify these two equations and then cross multiply and try to solve in a split in the middle term method. Okay. That's easy. And here taking LCM is important. Please children, take such examples and try to find LCM ahead, so that it will be very easy for you in the exam. Now let's consider this example. Okay, here when we observe, we have a bigger term like in the form of a fraction, and here as well. So normally like we do multiply 2, I mean just we'll open the brackets and multiply the 2 with the numerator. Here also multiply 9 with the numerator, and then taking LCM, again solving. Instead of doing this is like a tedious process. Even though you do this process, you'll get an answer. But here, what tip I'll suggest you here is, consider this term as some x. So already we have x, so let's consider it as y. So here we have x plus 2 by 2x minus 3, and here 2x minus 3 by x plus 2. So these are almost same, I mean reciprocal. Hence first consider, let x plus 2 by 2x minus 3 is equal to y, right? Then this term will become, because this is the reciprocal of this, I mean this term is reciprocal of this term, so we have assumed this term as y, hence this term will become as 1 by y. So let's transform our full equation into y. 2 into y minus 9 into 1 by y is equal to 3. Isn't it easy now? So we have just transformed this a big equation into a smaller, simpler form. So 2y minus 9 by y is equal to 3. Again taking LCM here. So we don't have a denominator here. Let it be 1. So 1 into y is our LCM, and we already have 1. We don't have y. So let's take multiply that y with our numerator, and then we already have y. So just 9 into 1 is 9. That is equal to 3. Now when we see this form, we obviously know that cross multiply. So hence the equation is 2y square minus 9 is equal to 3y. So let's bring, actually I have seen some of the students, like when they are in this form, again they'll get stuck, because it's not in the form of ax square plus bx plus c, like in a quadratic form. Hence please children, consider, remember that send all the variables and constants to one side, then it will become a quadratic equation. So 2y square getting 3y to the left side minus 9 is equal to 0. Now it's in the form of ax square plus bx plus c. And now it's easy to simplify from here. Like 2y square minus, when we multiply we have to get 9 2s are 18, minus 18, right, minus 18, and when we add minus 3, so 6 2s are 6 3s are 18 kada. So 6y minus 3y minus 9, am I right? 2y square 6 3s are 18, so 2 9s are 18, we have minus here, yeah, minus 6 minus 3 is minus 3y, so we have to get minus 3y, that means here minus and plus, right? Okay, let's take common 2y into y minus 3, right, plus 3 common y minus 3. So the equation now here we can take 2y plus 3 as common, 2y plus 3 and y minus 3, y minus 3. So now we have 2y is equal to 3, y is equal to 3. Okay, when we consider this as one of the roots, so this is not our solution. We have to, what we have considered y as x plus 2 by 2x minus 3. So let's equate that. X plus 2 by 2x minus 3 is equal to 3. Now when we cross multiply, we can solve for x. So when we are asked to find such expressions, I mean such a long equations, complex equations, this is one of the tips you can follow. Let's look at the next example. So we have got x square plus 5x minus a square plus a minus 6. Instead of constant c here, we have got one more quadratic equation. So in this, in such type of problems, we have to first solve this constant, because with this constant we cannot solve our x, because the equation will be like a square plus a minus 6 and x square. We have two variables over here. So let's try to solve this and see. So what's the common method? Like split in the middle term. So a square plus a minus 6 is equal to 0. A square 2 3s are, so 3a minus 2a minus 6 is equal to 0. 3a minus 2a is a, 3a into 2a is minus 6 is okay. A common, a plus 3 minus 2 as common, a plus 3 is equal to 0. Again here most of the children will do a mistake, like a, when here you are clear, yeah, here minus 2 as, take minus 2 as common, and we have arrived a plus 3 here, so the next term also should be in the form of a plus 3. That is like a blind memorization. So in order to get a plus 3, we have to take minus as common. When we take minus as common, the symbols inside the brackets will be interchanged. See here we have minus 2a, so minus 2 is taken as common. So instead of minus a, we got plus a. Instead of minus 6, we got plus here, plus 3. So this you have to remember. So taking a plus 3 and a minus 2 as common. So our equation is simplified in this form. Let us substitute those two factors here. So x square plus 5x minus a plus 3 into a minus 2. So this is our final equation now. Okay. So again now while doing split in the middle term, let's see. Okay. We want product of the terms here. We have 1. So 1 into this one is same. And let's see, a plus 3 minus a minus 2. When we do like this to get in the middle term, sum of the terms, a plus 3 minus a plus 2. Yeah, a is cancelled, 3 plus 2 is 5. So we are getting the 5x in the middle term as the middle term. So let's take this and this. X square plus, instead of 5x, let's substitute this. A plus 3 into x, right, and one more term minus a minus 2 into x. So this 5x is written in the form of a plus 3 into x minus a minus 2 into x, and let's continue the same constant part, 0. right? So again, yeah, most of the children will put, will miss to put x value here, x here, because actually we have a variable a already. So in we have x here and a here. In this confusion, we almost miss to put x. So please remember to carry x as it is. And now, yeah, in these two terms, let's split the terms. So we have x as common. So x plus a plus 3, right? Minus, okay, here in these two terms we have a minus 2 as common. So a minus 2, again, x plus a plus 3 is equal to 0. So we have taken minus as common, a minus 2. So the symbols should be interchanged inside the brackets. That's the rule we know. So instead of minus here, we got plus, and instead of minus again, we got plus. Yes, we are right. Now in this, we have these two as common. See children, here when you get confused how to take a common, first we are very clear that we got x plus a plus 3. Hence, the same expression has to come here as well. So in view of that, try to adjust the symbols and then see and verify whether you have adjusted correctly or not. Then it will be easy for you. So this is one of the tips to remember. Here also like same. Okay, that's very easy. Okay, let's take x minus a minus 2 is one term, and x plus a plus 3 is another term. So now what is the x value? X value is equal to, when I send it to other side, okay, we'll write this step also. 0, x plus a plus 3 is equal to 0. So x is equal to, when I send this whole term to the other side, it becomes plus a minus 2, like, and here minus a minus 3. So this is our final answer. Sorry, a plus 3. So x is equal to a minus 2. We get x value in terms of a variable, because we don't know the value of a. So this is our final answer. Next, let us discuss the next topic, that is nature of roots. We know that one of the another method to solve a quadratic equation is like using a quadratic formula, like minus b plus or minus square root of b square minus 4ac by 2a, right? So in order to find the nature of roots, it always depends upon the discriminant, we know, right? Using with symbol delta, we used to represent with delta equal to b square minus 4ac. In order to remember the roots which are real, equal, nature of roots is nothing but whether the roots are imaginary or real roots or distinct roots. So to find and to remember those conditions of this discriminant d, with this graphical method, it is easy to remember. Just I have drawn a very rough diagrams. Like here, first d is less than 0. That means b square minus 4ac is less than 0. So our parabola is not at all meeting any x-axis here. So no real roots. So no real roots here. Actually, one of the tips here to remember these conditions is using this graphical method. So just simply remember like a tabular column and this graphs. Then that will be easy for you to remember the roots, the nature of the roots. So it's clear here. D equal to 0. So we are exactly, our parabola is intersecting the x-axis at one point. So we have one real root here. And here d greater than 0. So we have got 2 points. Our parabola is meeting x-axis in 2 points. So two distinct roots. Two distinct roots. So it's nothing but two different roots. Here we'll get the same or equal roots. And here, please remember, it's equal roots, or even the coincident roots are also mean the same. So we used to come across the words like, zeros of the polynomial and roots. Zeros means nothing but the roots of the polynomial. Just don't get confused between the zeros or roots or anything. Yeah, you will see that topic in polynomials. So as of now, currently remember this graphical method to find the nature of the roots. Okay. Let us see a question based on the nature of the roots. So here the question is, for what value of k this equation is a perfect square? So when an equation has to become a perfect square, the condition is that the discriminant should be equal to 0. So this is the condition you have to remember. in order to solve this equation, I mean in order this equation or any equation to be a perfect square. So here again the equation is in the form of a quadratic equation because we have x square term, x term and a constant. I mean the degree is 2. Uh, so what is this discriminant value? I mean discriminant is b square minus 4ac and this should be equal to 0. This is the condition we have to know for a perfect square. Now b square, okay, so b, so the coefficient of x here is 2k plus 4. So b square is 2k plus 4 whole square minus 4 into a. A is again 4 minus k, c 8k plus 1 is equal to 0. We have 4 common. Yeah, again here, see, one of the tips we can follow here. See, we have 2 and 4 as common here. So let me take 2 as outside, I mean 2 as common. So we have k plus 2 inside. So this is whole square, right? Is the equation expression right? 2k plus 4, yeah. So this solves me actually easy because one of the tips here again is when we have equal to 0, so we can just take the take the constants or variables which are common to the other side, so they will become just 0 instead of solving those constants, I mean bigger numbers, bigger values. Just take common when you see such case like equal to 0. Here basically we don't have, only two terms are there. When we have two terms and equal to 0, taking common will works always good. I mean now you will be confused actually when I say this ahead. So let's solve the example and then you will understand in the process. So when I take this 2 as common, 2 into k plus 2 whole square. So let me expand this directly here. So 2 square is 4 and inside a plus b whole square. So it's a square plus b square plus 2ab. I think you are all aware of these identities, so I don't have to write the identity again. Here we have a as k and b as 2. So here let me put 4 as it is because we already have 4 here. So I might take 4 as common and that will go to the other side, so it will become 0. So easy for me to solve the calculations in this way. So let's use distributive property over here. 4 8s are 32, 4 8s are 32, 4 1s are 4, minus k into 8k, that is minus 8k square, minus into plus minus k. Please children remember, while doing the distributive property also still some of the students are making mistakes. So practice well using this distributive property. Like when we have especially this minus symbol, students make mistakes while carrying the symbols. So are we doing correct now? See, minus 8k into k minus 8k square minus into plus minus k. Yeah. So here this is one term minus this is another term for me. So in these two terms 4 is common. So let me take 4 as common and just open the brackets here. So k square plus 4 plus 2 to the 4, 4k. Okay, already we have taken 4 outside, so minus is there. So let's open the bracket and send minus inside. So minus 32k minus into plus minus 4. Please don't multiply this 4. 4 is already outside. Don't get confused. Only the minus symbol. So minus 4 minus into minus plus 8k square minus into minus plus k is equal to 0. So here we have like this is one term into this whole expression is another term. Remember, like it's a into b. So when we have a into b, we can send either a or b to the right side. So here don't get confused like can we send 4 to the other side or not. Just think that this is one term and this whole bracket thing is another term. So it's as simple as like a into b. So 4 will send outside, so it becomes 0, right side. So it becomes 0 by 4, that's 0. So let's solve inside. K square. So find out the like terms. 9k square plus, next we'll go with k. Here also, please follow the quadratic equation form. Instead of getting confused first what to what like terms to choose. So just go blindly with the quadratic equation form. So k square is already done. Then look for k. 4k plus k. So it's 5k. Here we have 4k, k. Sorry, 5k and minus 32k. We have one more k here. So 32 minus 5, 27, minus 27k, bigger number is minus. Please children, remember to carry the symbols here. Most of the children will leave minus here and this they will go with the positive sign. Please remember these are the small mistakes which takes longer time for you to sort it out, like to find your mistake in the exam. This is one of the time waste thing is this one. So we have 9k square minus 27k. Okay, we have plus 4 minus 4. I can cancel. So what is left? I think, yeah, everything is done. So equal to 0. Again, see, we have two terms, 0. Taking common should be your easiest option. Even we can take k also common. 9k. Let's take 9k as common. So the remaining is here k minus 9 3s are 27, 3. Already k is outside, so 0. So 9k when I sign to the other side, it becomes 0 and k minus 3 is equal to 0. This implies k is equal to 3. Isn't it easy when we solve like this? So taking common will definitely help you in such cases. Please do follow this tip. And any more doubts? Yeah, that's all for today. And please children, do follow these tips and practice the worksheet given below. And in the next video, let's cover the word problems of quadratic equations. So hope you liked the video, and if anything is there, just please do comment in the comment section. And if you liked the video, please subscribe it and share it with your friends. Bye.